Hi, Sue. Are you able to hear me okay? All right. I'm not going to make you unmute. I'm going to, oh,
Yes.
okay, good. You can mute yourself if you want. You can be unmuted since it's just me and you. If you have any questions, feel free to jump in and ask. Otherwise, I'm just going to start my little lesson here, okay?
Sound
But I guess my first question is, have you been to any of my presentations before?
yes, at the Hackett's at the wait a minute, trying to think what library. Um Long Valley Library.
Oh, okay, great. Do you remember which class you saw there?
Oh, I saw two. Both of them were amazing.
Oh, good. Well, hopefully then this won't be too boring. If
Oh
sometimes
no.
it's sometimes it's nice, even if this is one that you've heard before, then sometimes it's good to hear it again, even so, or if it's brand new to you, then wonderful. Um, but yeah, feel free to jump in, ask any questions that you might have. Um, so you already know this part. Who am I? I'm Elyse
Yes.
Cross, and I'm a professional genealogist. My company's Last Leaf Genealogy. I'm a genetic genealogist too. That's my favorite thing, and that's what we're going to be talking about today. And that's so exciting for me. It's my I literally had a dream about it the other night. I love it so much. Um, Also, I make sure to tell everyone that I'm a member of the Church of Jesus Christ of Latter-day Saints, also known as Mormons. Um, the church is the main financial backing of FamilySearch.org, which is free, billions of records available for free there. And here in New Jersey, there are not many of us members of the church. Usually you're going to find us out in Utah. So I'm kind of celebrity in the genealogical community in New Jersey when I tell people I'm a
There.
member of the church. So, and here's, I always have one joke. So here's one joke. As you are researching your family history, you will learn, like this person did, that you have come from a long line of dead people.
Oh, I
So we
love it.
all have that in common. All right. So what is genetic genealogy? What does it mean when we hear that? Well, the International Society of Genetic Genealogy, which you can find here at isog.org, defines it as the use of DNA testing in combination with traditional genealogical and historical records to infer the relationship between individuals. So, what that means basically is we have our DNA tests that we take at any of the many commercial DNA testing companies, combined with the traditional genealogy that we all do, right? Records, family trees, all that stuff. You put those two things together and you get a family tree. And that family tree is established not just through paperwork, but through science, through genetics. Some people discover that their tree is different than they expected, that maybe they have a biological genetic tree and also a different paper tree. And it can be difficult. Some people, if it's surprising, obviously it can be quite shocking. Um, and for others, it's exciting because it answers questions that they've had for a long time. So that's the basis of genetic genealogy. Now, sometimes you'll hear in our world today, um, you'll hear investigative genetic genealogy or forensic genetic genealogy. They are two different things. Forensic genetic genealogy, or FGG, that is genetic genealogy used for any purpose in law having to do with law. So it could be for inheritances, wills, things like that. They're trying to find an ancestor who's inherited something. Then there's investigational genetic genealogy, which is IgG, and that's where you get into more, trying to identify DNA that's been left on a victim or trying to identify an unknown human remains. So FGG and IgG are very exciting, fairly new tools that law enforcement uses. So let's talk a little bit about consumer DNA testing. So there are 3 different types of DNA tests. The most common one that we talk about today is autosomal DNA. The other types of DNA tests have really kind of fallen by the wayside because they just don't necessarily meet the needs of that people are looking for these days. Y DNA tests obviously can only be taken by genetic males. And then there's mitochondrial DNA, which is not as helpful in the things that are interesting and exciting for people who are taking DNA tests today. So usually when you're talking about a DNA test, you're talking about autosomal DNA. And here are 4 of the main companies that you'll hear that do consumer DNA testing. And there are many, many more. But obviously we've got Ancestry. They're the largest. They have the largest database. If I have someone who's looking for their birth family, their biological family, I'll say, take an Ancestry test. The 23andMe, like others, they focus more on health. You're going to, they'll have DNA matches out there, but usually people are taking those tests to find health information. Ancestry has started to kind of get into that a little bit, but not very much. A lot of people also go on Ancestry to find their ethnicity. They want to know what countries they come from. MyHeritage and Family Tree DNA and others, one of the things that they have that Ancestry and 23andMe don't is that they allow you to take your raw DNA and upload it there. So you can take a test at Ancestry or 23andMe. You can upload it at MyHeritage, also GEDmatch, Family Tree DNA. And then you can find people who may have taken a test with another company and find more relatives that way. But those people would also have had to do the same thing. So that's kind of that overview. Now, a quick overview of what DNA is, right? So DNA, deoxyribonucleic acid, it's just all you need to know in order to use it for your research is that it carries genetic material. It's found in almost every cell of our bodies. And autosomal DNA, the kind that we're going to be talking about with these commercial tests, it's measured in centimorgans or CMs. And centimorgans, you have to think of it as kind of like inches or feet. Think of it as like a length. That's the easiest way. So generally, well, we'll get there, but so DNA is passed down through generations. We've got an example here we've got grandfather, grandmother, grandfather, grandmother. Here's father, his mother, her father, her mother. And then here's you, and you've got, you should have about a quarter of your DNA from each one of your grandparents, right? Because you have half your DNA from your dad, half your DNA from your mom. But also in this half from your dad, you've got half from his parents, but actually they got half from their parents and a quarter from their grandparents. So it really gets down to which half, let's say here's grandfather here, dad gets half of his DNA from this grandfather. Well, if he's got a twin brother, he'll get the exact same half. But if he has just a regular brother, that brother will have gotten half, but it could be a completely different half. So that's why we share, it combines unpredictably. You can't really predict which pieces of DNA are going to be handed down to which descendant. That's why some people may have a relationship, may show a genetic relationship with a distant ancestor, but a sibling might not, because they didn't get that little portion of DNA passed down to them. So it can be really helpful to have siblings take DNA tests, because those little segments get passed down unpredictably. And again, the uninterrupted pieces of inherited centimorgans are called segments. So when we talk about segment, it really is just that. It's a little, it's a piece, a centimorgan that's unbroken, or a strand of centimorgans that's unbroken. That's just been handed down through generations. So those are segments. And generally, the more DNA you share with the person, the more closely you're related. So you're going to expect that you share a lot more DNA with your parent than you're going to share with your first cousin. But because of this unpredictable recombination of DNA, you might not share any DNA with your distant relatives. It doesn't mean that you're not related to them. It just means that it combines that unpredictable way. And you may have family members who do have that little segment that's been passed down, but you don't. So don't worry if you don't see a connection that you would like to see with those distant relatives. Now, there are some relatives, if you don't see a connection, you need to worry, like a parent, grandparent, siblings, stuff like that. You are 100% going to share DNA with them. But the further back you go, that it's not going to necessarily show. So I wanted to kind of illustrate this with this example. So I fortunately have had 3 first cousins, and they're verifiable first cousins, take a DNA test from Ancestry. So this is what it looks like, my results with them. So this cousin here, this is a paternal cousin. So this is my paternal cousin. B and N are both maternal cousins, as you can see there. So my paternal cousin K, we share 1,000 centimorgans of DNA. So that's a good chunk. We share a lot of DNA. Now, with my cousin B, we only share 802. And with cousin N, we share 725. So these are all verified first cousins, but we share a vastly different amount of DNA. Now, between B and N, I don't know how much DNA they share between each other because that's something that Ancestry doesn't allow me to see. One of them would have to share their results with me for me to be able to see it. But all I know is how much I share with each one of them. So you can see here that it looks like I'm genetically much more closely related to K than I am to N. But in terms of actual generations of different, it's exactly the same. So that's just DNA, right? That's just how it recombines unpredictably. So who uses this? Who uses this information? What good does this do showing how much DNA you share with another person? Well, hobbyists use it. That's most of us, right? We do it as a hobby. Most of the genetic genealogy I do is just as a hobby. I also do volunteer work. I have yet to be paid to do genetic genealogy because when as a search angel, it's volunteer. You do it to be helpful. I'd love to work with, and I'm working with law enforcement, given some presentations and some information to them. So anyway, it's kind of the Wild West out there as far as that goes. But people who are searching for unknown parents or other ancestors, those are the birth families, the biological families and the searchers that I work with. They want to know who are my biological parents, who's my biological dad, who is, my biological grandfather. We never knew, stuff like that. And I can try to help them answer those questions. Researchers attempting to extend their trees. That's really interesting. And I do have an example of that today. And also researchers attempting to prove relationships. Like, let's say you've always heard that this, George Howell was the son of James and Phyllis, but you don't know that for sure. It's just been, but some people say that they're actually children of another couple. So you can look at people's DNA and see what you can figure out that way. So that's another reason why people may use genetic genealogy. And again, as we talked about law enforcement with identifying human remains and trying to identify criminals. So let's give an example of extending your tree using DNA on ancestry.com. And again, we're going to talk about Ancestry because it's the largest database of consumer DNA testers, and most people are familiar with it. It's vastly, it beats every other company out by miles as in terms of its size. So we're just talking about Ancestry DNA today. The principles are the same, but the way the layout of a website might be, all that is going to be a little different. So keep that in mind if you have tested on a different site or plan to test. It'll look different, but the principles are still the same. So this George Ross here is my father-in-law. And when I married my husband, they only had the family tree going back to his paternal grandfather, Nathaniel Ross, who you can see here. And Nathaniel, well, George Albert Ross, he came over from Ireland. He was a first generation immigrant, and his parents and some of his siblings had stayed in Ireland. So Nathaniel and Anna Eliza, they never left Ireland. George and most of his siblings did. But because of record loss in Ireland and the difficulty of researching, we were never really able to pin down who Nathaniel's parents were. Lot of same and similar names in that area. Also, we knew that where the Ross family ended up in Ireland was not where they started, because he had left where he started and had gone to school. So how are you going to get back without, having a real paper trail to follow? So we were kind of flummoxed, right? We could make some assumptions, but that's always tough. You don't want to base a whole tree off of assumptions. So George, well, first my husband took a DNA test, and then my father-in-law said, you know what, I'm going to go ahead and take one too, because the further back you can go in generations, the better matches you're going to get, right? Because you're getting closer to the source. So George decided that he would take a DNA test. And the way it looks on Ancestry, when you get your DNA results, it takes a few weeks. It's super exciting. You get the text or the email that your results are in, and you go and check it out. And this is what you see. You see something that looks like this. And there's 3 different things that you can choose here. You can choose to look at your origins, which a lot of people are excited about. They get to see their ethnicity, what countries they've come from. That's always exciting. And one thing to keep in mind, though, is that their algorithms for using that change all the time. I took my first DNA test years and years and years ago, and it is completely different now than it used to be. And that just means that they're getting better at it. It can be a little surprising, though, and some people don't like what they see because they're like, well, for example, George here, we know his family came straight from Ireland. This whole section should be Irish, but it's not. It's Irish, Scottish, and English, because those are your more ancestral roots. So it doesn't mean that's not the country that he came from. We know he came from Ireland, but what are his ancestral roots are from those other places as well. So anyway, the 3 things here are origins, DNA matches, and through lines. Now, 2 of these we use for in genetic genealogy research. Now, through lines you can use, but I'm going to give you a big caution here. It says right here in this box highlighted, through lines uses ancestry trees to suggest how George Ross may be related to their DNA matches through common ancestors. So what it's going to do is it's going to look at my tree, because I've got George linked to my tree, and it's going to show other people's trees. And Ancestry's computer is going to look through and say, well, this person has, this familiar name in here, and all these other trees show that this guy's ancestor is whoever. And it's going to say, so that might be your ancestor as well. Well, what happens on Ancestry is a lot of people are copying trees, right? They're copying their own and other people's trees. And you get a lot of misinformation that's also copied there too. So you can see, it'll show you, oh, this is your great grandfather. Well, it may be true, it may not be true. Also, if you have an adoptee, like I work with a lot of the adoptees, it'll suggest, their adoptive family in there. That's not helping me at all. I want to know their biological family. So it's really just looking at other people's trees and what it's finding out in there. It's not looking at the DNA at all. So when you're looking at through lines, that's all that it's really suggesting. It's looking at your matches and what's in their trees. So 2 people, whatever. Anyway, so what we're going to focus on here are just the DNA matches. So let's review those results. So in those matches, you're going to see all these different ways that you can look at them. You can look at all the matches. You can look to see if there are common ancestors in the trees that they have, if you've taken notes on anybody, all kinds of stuff, right? But what we're going to focus on today is right here where it says by parent. This is something that's fairly new that we used to have to do on our own. We used to have to separate matches into parent by parent. But Ancestry does that for us now. It used to be beta, and now it's just part of the process. So this is what it looks like. Now, because I've gone into George's DNA matches, I've marked them paternal and maternal myself. What you'll see, unless you had a parent who took a DNA test, it'll say parent 1 and parent 2. Right here, it says, I've written this in. I selected that by edit parent. I clicked on this and I selected paternal. But when you start off, it'll say parent 1 or parent 2. And how do you know which one is which? Well, in this case, I know that George's dad came from Ireland, and I know his mom came from Finland. So that was super easy to know which ones were which. Also easy to figure out because a common last name in these trees is Ross. So I knew Ross is the paternal line. So usually, unless it's a family where it's an adoptee who doesn't know any of their biological family, you're going to know one or the other at first. So that's how I went ahead and made that selection there. So I know I'm looking to extend this paternal line, so I'm just going to focus on these paternal matches. So here's what we got. We've got all these people who we know are related to George through his father. And so where do I start? Well, what I'm going to look at are people who are good matches for me to do some research on. So let's start up here at the top because the list is going to start with people that we share the most DNA with down to the least. And what we would love to see, if for an adoptee, right, you'd love to see a mom or a dad who's tested, or a full brother or full sister. And when you don't see that, you might get a little frustrated. But it doesn't mean you can't solve the mystery. So right here, let's start with J.E. She and George share 276 centimorgans of DNA. So think of it as inches, right? So 276 inches they share. And so we go over here and we see, oh gosh, that's great. She's got a public tree. That means I can see her family tree, at least the deceased people. And there's only 5 people in it, but who knows? It might be exciting. There might be something good in there. Also, benefit, it's linked. So that means that she has put herself into her own tree. If you don't do that, then we don't know who the tester is in that tree. We just know that user has a tree. It may not even be their own tree. It could be their spouse's tree or their friend's tree. So a linked tree is super important. So let's click on that and see what JE's tree looks like. And it's not much, right? All the living people are private. And then we see Albert, and I've taken out the last name, but it wasn't helpful to us at all. No way to figure out who's Albert, who's JE. I don't know. It's a mystery. That's not helping me at all. So let's go on to the next one. We've got JA, 201 centimorgans, but guess what? No trees. He not only doesn't have himself linked to a tree, but he's got no trees at all. And since his name was a common name, again, I'm not sharing it just for confidentiality, but very common name, nothing I could do with that. So we're leaving that behind. Then we go down to SE. He's got an unlinked tree. Maybe we can kind of figure out who he might be, but not for sure. Then down here, we've got DO. She's got 831 people in her tree, but guess what? It's locked. It's private. So I would have to reach out to her and say, hey, would you share this tree with me? And most likely she's going to say no. And she's going to say, who in the world are you? Or she's never going to even see her messages because she hasn't logged into Ancestry in a year. And so now, fortunately, I do know her. She's actually a relative that we have come in contact with. And she did share her tree with me eventually. So that was really exciting. But in this scenario, we're going to say we don't know her. So now we're all the way down here to one Jeha. He's got a public linked tree, 9 people in it. Let's take a look. And what do we see? We see a shared name, Martha Ross. Oh my gosh, how exciting is this? Now, we don't know for sure yet if that is how George is related to Jeha. Is it through Martha Ross? Is it through this other family? We don't know for 100% sure, right? We can make kind of a fairly good guess that it's probably through Martha Ross, right? Because we know it's related on that paternal line, but not 100% sure yet. But you got to start somewhere, and this is good enough. So we've got this Martha Ross and her family. So the first thing you do with the first match that you can, who has the highest number of centimorgans shared with you, you're going to start building a tree. So let's take Martha Ross and let's build her tree. And I did. So we put her into family search. We put her into ancestry, and tons and tons of records for her. It was really, really great. You can see she was born in Cross Haven. She died in Philadelphia. So she again was an immigrant. Found this great obituary for her saying that she was buried in Holy Cross Cemetery. Looks like she was Catholic. That's important when you're doing Irish ancestry. This was her, I think, her husband's naturalization record. You can see here's her birth information. That's where I got that from, Cross Haven, Ireland. And then here is her death certificate showing that she was actually born in County Cork, Ireland, which, guess what, is where George Ross's grandfather was born. We're looking for George Ross's grandfather. We're looking for his great grandfather. So County Cork, we're in County Cork, great. Mom's name, Jane Kingston. Father's name, John Ross. So this is Martha's family. So this is great. I'm loving this. This is all working out. The only thing that I'm not loving is that Martha's Catholic and the other Ross descendants were Church of Ireland. So it's not a big it doesn't tell us that it can't be, but it's something we want to keep in mind, right? We need some really good evidence in order to move on and say that this is actually the same family. But here's what we've got right now, because I did this research on Martha Ross. I've got both of her parents. I've got one set of grandparents for her and one grandfather. So this is just from building on this tree from Martha Ross, who I am starting with the assumption that this is the family, this is the relation. Now here we get to the part where we need to talk about triangulation, because we don't know, right, that Martha is the actual connection between the 2 people who've taken the test. George took a test, Jeha took a test. Are they related through Martha? The only way we can do that is to try to find the same people in Jeha's tree and another person's tree. So this is what triangulation looks like. It's when at least 3 people share DNA, then you can attempt to identify their common ancestor. So for example, we're going to use my cousins again. Here's me, cousin B, and cousin N. We all share segments of DNA with our grandfather. We all share segments of DNA with our grandmother. So if I can find those connections, if let's say I didn't know who B and N were, but I mapped out a tree for them, then I would be able to know we shared ancestors. This is what it looks like. Let's say B's mother was May Gonring, and May's mother was parents were Michael and Patricia. Let's say N was Sally Gonring as a mother, and her parents were Michael and Patricia. Let's say I didn't know who Elizabeth's parents were. Well, because of how much DNA I share with these 2 people, and because Michael and Patricia had a daughter named Elizabeth, I would know, okay, that's my mother or that's her parents, right? Because they fit into this tree. The amount of DNA shared between the relations are correct. It's all right there. Now I've got my triangulation. So that's what we've got to do here. Right now we've got George in this box. We've got Jeha in this box. We need one more person to make that triangulation. Now, some people ask what I use to do this because I use this all the time in drawing out these family trees. It's a little program called Scalpel. Love it. It's awesome and cheap. So let's try to triangulate. So George Ross and Jeha are related to each other. If I go and click on his name, I'll get to this screen where I can look at the shared matches. Now, these are matches that George and Jeha share with each other. So I'm not looking at anybody else on that paternal line. I'm only looking at this connection between George and Jeha. And I get this whole list of people. Now I have to do the same thing, right? I'm looking at every single one of these names. Do they have a tree? Do they have maybe a unique name, something I could research? I had to go all the way down here to Frank till I got somebody who had a public linked tree with a certain, with a reasonable number of people in it. But interestingly, if you look up here, you see this name Kingston. And this was a name that I had noticed in Martha's family. So that's boding well for our triangulation. Maybe we'll get something there. So first thing I'm going to do, I'm going to look at Frank's tree and I'm going to see if it's possible for me to triangulate something there. So 42 people, let's take a look at what he has. And we see here that Kingston name, right? And we know that Kingston name was in Martha's tree as well. And we also saw it at the top of that list. Now, in this particular tree, all these people, they came from, I think, Germany. So I didn't even have to worry about any of these being that connection. I knew the connection was going to be from Frank, his father, Frank. And then I think even this Frank was from some other country. So I knew it had to be through Catherine Kingston. So that was an easy one to do. But I still had to build this tree. And I did. So we get all the way down here and guess who Catherine's parents were? Daniel Kingston and Anne Ross. And guess who Anne Ross's parents were? John Ross and Anne Kingston. Those were the same parents as Martha Ross. So this is what it ended up looking like. We've got John, who was our Jeha, and we've got Frank Curtis over here. And I went ahead and put and found out that one of the other common names that I couldn't figure out, that didn't have a tree, it was actually John's brother, Joseph. And then because I was able to extrapolate some information, I identified these two other matches. So I always put my matches in blue like this with the number of centimorgans they share with the tester. So that's what this little graph means. But now I've got to figure out, since I've got this genetic tree here, these are how all these testers fit in with each other, right? But where does George fit in there? We know that George, his father Nathaniel, where do they fit in to this family tree? They've got to fit somewhere, but where? So now we're going to look at some probabilities. You know, there's a whole bunch of ways they could fit. So first we have to look at it and we kind of just have to make our own assumption, right? And I looked at this and I said, well, he's got that really close match with Martha's descendants, Joseph and John. So I said, I think that Martha and Nathaniel were probably brother and sister. And then Nathaniel had his son George. He had his son George. This is my first assumption I'm going to make, just because of that close relationship. But I don't know if this is really true, how they would fit in. So we've got a great tool called, first to show you kind of how to look at this, right? So this is how you can use this kind of chart to just be able to determine what these relationships are. So up here is the parent. Now we're not looking at both parents, right? Because we're only looking at the descendants of John Ross and Anne Kingston. So we're not looking at John and his wife here. We're just looking at John. So that's the parent. Then in this line here, you're going to have siblings. So Martha and Nathaniel are siblings. In this line here, we've got Joseph and George. They're going to be first cousins, right? Because their parents are siblings. And then finally down here on this line, you've got second cousins. So George and these two guys, Joseph and John, would be second cousins if I'm correct, if my little assumption here, my hypothesis is correct. So you can see kind of how to look at this. So I'm going to need to see Does it make sense if you share 138 or 145 centimorgans with somebody? Could they be second cousins? Does that make sense? So there's a cool little tool. Let's start with that 145. It's called the Shared Centimorgan Project. It's on DNApainter.com. You can go there. This is what all the professionals use. It's an amazing free tool that a wonderful guy, Blaine Bettinger, has put together through hours and hours of research and volunteers. And all you do is you just input the number of shared centimorgans or the percent of DNA that you share with someone. And so we went ahead and entered 145, and it says, here's all the ways that you could be related to that person and what's most likely. So we're going to focus on the first two groups. That's what I try to do. I really, really want to see that I'm within those first two main categories, either the most common or the second most common ways that the relationship might be. Now, again, the further back in time you go, the more likely you might find an outlier, but hopefully you're not going to find an outlier with a first cousin or sibling or something. You might want to try to talk yourself into it being an outlier, but usually it's not. It's just something you're going to have to deal with and figure out that issue. So anyway, so looking at these, I can say, well, I know that John and George are not happy, that John is not George's half great uncle, right? It's not possible. I know that he's not his niece or nephew. You just know by looking at ages, looking at the family, you know it can't be that. So looking at all these different things, I can rule out a lot of these relationships. So here's our second cousin, right? It's in that second group. So it's not great, but it's still possible that this is a good relationship. And I was able to take out all of these relationships based on age and other family relationships, except for half second cousin. So there's a possibility that they only share one set of, or one great grandparent instead of two great grandparents, which is okay as long as that great grandparent is John Ross. So, so they could be second cousins or half second cousins, but we're going to assume second cousins for now. That's close enough. So that still fits, right? Now let's check some of our other relationships here. So we've got Thelma. Now let's see. We're going to start up here this time at the closest shared ancestor is John Ross and Ann Kingston. Between George and Thelma, this is the most recent common ancestor. For John and Joseph, it was John was the most recent common ancestor. But for Thelma, it's going to be this couple. So let's start up there, their parents. Now this row, we've got Helena and Anne. They're going to be siblings. Edmund and Catherine, they're first cousins because their parents are siblings. Thelma and Frank, they're second cousins. But we have to go down here to get to George, right? Because he's not a second cousin. He's a second cousin once removed. So Thelma is a generation older than George. So you stop here and then you go down one more and say once removed. So even if George was up here, let's say we were comparing this guy and Jeff, they would be also second cousins once removed because you always stop at the higher generation. That's how you figure out the once removed. So we're going to go back to our handy tool. We're going to take that 139 centimorgans and we're going to see if it makes sense for them to be second cousins once removed. We type in that 139, we get our results. And where's second cousin once removed? It's right up there in the top. So that's fantastic. So we know it's most likely that they're second cousin once removed. Let's try Frank. Again, parent, sibling, first cousin, second cousin row. Now they're on the same row, so they're third cousins. So let's check out that 122 centimorgans. Could they be third cousins? Plug it in. Here's our results. Where's our third cousin? It's the second, but we're still okay. We want it to be one of those two, so it makes sense. So because of this, all these people we know are related to each other. Joseph, John, Thelma, Jeff, Frank, George, they're all related to each other. We've been able to find the paper trail that shows that they're all descendants of John and Ann Kingston. Because of how much DNA they share with each other, it makes sense that George Ross is right here also in the family tree. So again, we say, what's genetic genealogy? It's that science, those DNA tests, plus the paperwork equals the family tree. So with that, I felt confident in putting the parents of Nathaniel Ross as John Ross and Jane Kingston, and then John Ross and Ann Kingston. And what I did was then, now that I've got this idea that these are the parents, now of all the John Rosses in Cork County, of all the Rosses in Cork County, Cork, this is the one I knew to focus on. And guess what? They had a son named Nathaniel. And I found the whole family. So I went from knowing nothing, not knowing where to look in that whole county, to being pointed right to these people and their son, Nathaniel. And I've got that science to back up this relationship here. So there's Jane. Now, through lines, again, just a little bit this is just an example of what it looks like. Again, you can use it for tips, hints, ideas, but don't use it in place of going through those matches, because again, and doing your own research, because again, you're relying on other people's research and just kind of crowdsourcing, and you don't want to do that. So it'll show up at the top that George Ross may be related to this person who took this test through John Ross. And that's what we thought, right? That was our assumption. So through lines is telling us that here's another ancestor we didn't even, or another relative we didn't even know about. I didn't even have in my little tree that he could also be related to in this way. So that's helpful to us because it adds another bit of evidence to our hypothesis. And another sister to Nathaniel up there is Eliza, and found her on the censuses. And if we assume that I am down here, or IO is her username, if she did her ancestry correct and Eliza's really her ancestor, then we've got another sister. So there's Nathaniel and Eliza's brother and sister. And then, of course, they always tell you evaluate. Don't just accept it, right? Evaluate it. So before I keep going, I see some things in the chat. So I'm going to open up the chat and see if there's anything here. Yes, good to know about copying trees, because you never want to just, you always want to take other people's research as a hint, right? It's a place to start, but you don't ever want to just take it at face value, because you can end up just copying mistakes. Alexandra says, when I go back in records, census, et cetera, there are different spellings of last names. Yeah, and that's a common problem. It really is. It's interesting. It's just a matter of fact that people, they honestly didn't really worry too much about spelling for a long time. Even dates, they may not have worried too much about. I was born in June, that maybe it was the 12th or 13th, like they didn't know. You would have different relatives spelling their last name in completely different names. You could see them on completely different spellings on different forms of the same person in the same year. So it wasn't that important to them. So it can be difficult, but it's part of the puzzle, right? It's part of the fun adventure. Okay, so any questions? I know we had some people who kind of came in late, might have missed a little bit of in the beginning about what we were talking about with centimorgans and what DNA is, but I'm happy to answer any questions now before we move on to kind of how I'm going to end with just a little story of kind of using this in a biological family search. Okay.
Yeah, feel free to unmute yourselves if you have a question for Elyse. Or you could type it in the chat.
Yeah, or type it in the chat. We can look at it at the end too. All right. So I'm going to tell you this story. This is one of my favorite stories. So this is about a man named Robert Gordon Wick. And cute guy, handsome guy, apparently very sweet, wonderful man. Oh, sorry, I've got a dog sitting next to me. And that is his lovely wife, Marjorie. They were married for many, many years. He served in the Marine Corps, I believe. And They had a long, long, happy marriage, and many wonderful children together. Now, Robert was adopted, and he wasn't super concerned about his adopted fam or his biological family. His mom was his mom, and he wasn't worried about it. It didn't really concern him. But Marjorie here, she was very interested. She wanted to find out her husband's family. Now, this I can appreciate because I do a lot of work on my husband's family, as you can see from this little presentation here. So I get Marjorie. She was interested. She wanted to know. And Robert was like, sure, go ahead, honey. You can do whatever you want to do. So Marjorie started this search. She started by going to the adoption agency. They knew what agency he was adopted from. They also talked to Robert's mom, tried to get information that they could from her before she passed away. And through the adoption agency and his adopted mom, they found the story of the doctor and the nurse. And the story was that in World War I, a doctor and a nurse met each other in France, fell in love, and she became pregnant with Robert. And the doctor was married and had children, and the nurse was not married, but because he was, and it was taboo, and they weren't able to be together. And so she placed the baby for adoption. And actually, Robert's mom had met the biological mother, the adopted mother and biological mother had met a couple of times because Robert wasn't adopted until he was a little bit older. So he was in the kind of orphanage for a while with both moms visiting him for a bit. So this is what we got. And then Marjorie took this little story and started sending snail mail letters to people like this one here. She sent a letter. She was also told that the mother was from Iowa. The baby was placed for adoption in Minnesota at a Lutheran hospital, so they were Lutheran. Anyway, so that kind of gave her some hints too. So she started sending email. She started sending snail mail to Iowa to try to get some information. But didn't really do a whole lot. So when this family first came to me years ago, before any of them had taken a DNA test, they said, hey, can you try to find the biological mother? This is what we know. Her name is Meta Laura Schmidt. And so doing traditional genealogy like we all do, and with her being a nurse and the other information that we had, this is what we were able to find out. She was born 1897. She did work as a nurse. And here's her in a census. This is, I believe, the 1920 census. She's right here working as a nurse at a hospital in Iowa. She actually worked here at the Lutheran Hospital in Hampton, Iowa. And this is a picture of what it looked like at the time. And then interestingly, you can see that from this news article that Hampton Lutheran Hospital was received an urgent call for nurses to go to Camp Dodge to assist in the care of influenza patients, because this is 1918 and it is the Spanish flu. And if you know your history, you know 1918 was a terrible time, and especially for these camps. So Camp Dodge needed nurses to, I'm really sorry about my dog. Camp Dodge needed nurses. And so guess who was one of the nurses who were released from the hospital to go work at Camp Dodge? Meta Schmidt. Now, Robert, one of the first things I noticed, Robert was born in 1921. The chance that a doctor and nurse were still in France for World War I in 1921 was pretty low. The war was over by then. So it really didn't make a whole lot of sense for them to be there. I did do a lot of research to see if there's anything to find out that actually happened. But this particular bit of information gave me what I thought was kind of a reason to think, to have kind of this military idea here, this World War I idea, because she did work at Camp Dodge, which was an army camp. So maybe that is where part of that story came from. I also found this. little postcard that shows nurses working at Camp Dodge during the epidemic. And it was neat to think, we don't have a picture of Meta, but one of those nurses could be her. We know she dressed like that and worked in a room like that. And we all know those masks now. But yeah, so that was really neat to find that postcard. So before 1922, it's important for us to know where Meta was. If we're going to also try to find the father, right? Where was the mother? Well, we know she lived in St. Ansgar. That's where she was born, where her family was. Also in Hampton, where she was a nurse in Camp Dodge. She did get married, not until 1926. So she was single when Robert was born in 1921. And she never had any other children. Robert was the only son that she ever had. She died on March 31st, 1969. So from this information about Meta and what we learned so far, we can make some assumptions about the biological father. We can assume he was born probably between 1861 and 1901, because that would make him between 20 and 60 in 1921. So, right, he was probably right in the middle there. He probably wasn't as young as 20 or as old as 60, but those are our most likely years. We can make the assumption that he worked as a doctor, right? The nurse was correct. We did get a nurse in there, so we can assume the biological father was a doctor. We can assume he lived near Meta, since Meta never went to France. She really just stayed in Iowa her whole life. We look at where Meta lived, and here are the different places. Hampton, there's Camp Dodge down there, there's St. Ansgar up there. And interestingly, St. Ansgar, you can't really see, but right here is the Minnesota border. So he was placed for adoption up there in Minnesota. And then also she spent the last part of her life in Vinton, which was over there. So what are we going to do, right? First thing we're going to do, we're going to look at our matches. We're going to say, okay, so while we got Robert's son agreed to take a DNA test. It was actually Robert's grandson that was interested in completing this research, but Robert's son said, sure, I'll take a DNA test, because you want to get as close to the people as you possibly can. So let's start at the top, right? We're going to look at the best DNA match that we've got. But before we do that, there was something that stuck out to me, and that was this last name, Millard. We see that 3 times in this list of people, Millard. And I've changed the first names for privacy, but that last name, Millard, is the correct name. So that was just something I noted. But again, we want to stop at the top. We've got Colleen Overton. Now, that's a unique name, right? It's spelled unique. It's not John Smith. You're not going to have a million of them. Also, I'm going to guess she's from Minnesota, Iowa, something like that, right? Because we know this is where the biological father would have been from. Now, again, I'm not going to go through the process, but I did narrow this down to the biological father's side. These are not people who are related to the biological mother. So anyway, we've got Colleen. She's our closest that we're going to get, but she doesn't have a tree online. But we're still going to do some Google searching and other searching. And because of her unique name, I was able to build a tree for her. I said, you know what? I think this is our Colleen Overton. Found her maiden name, did all this research, and guess what I found in her tree down here? That last name, Millard. And once I saw that Millard, I said, oh, I think I've got it. Now, this was an easy one, because this is what I was able to do. All these shared matches between Colleen and Dave, who was the son of Robert, they had all these matches, and all these people were descendants of Henry and Martha Millard. So I've got this tree. All these matches are related and descended from Henry and Martha. I can assume that Dave, my tester, is related to Henry and Martha too, right? He's in this family somewhere. Where am I going to put him? I have to make an assumption. So this was my assumption. Because of how much DNA they share, just by looking at it, because I've done it for a while, right? I'm like, okay, this is where I think he's going to fit in. I think that Robert's father was also a son of Henry and Martha. So let's look at Henry and Martha's family. Does it make sense? Could a son be the father of Robert? So here's Henry and Martha, right? Go to Ancestry, start building a tree for them. They had these, what is this, 7 children. So first we don't have to worry about the girls. We know that we're looking for a biological father. So we're not even going to look at the girls. Then we can take out these 3 boys because they had descendants who tested. And let's go back and take a look real quick. William had these descendants take a DNA test at Ancestry. If Robert was a descendant of William, he would share a lot more DNA with these guys. So we know we don't have to worry about William. Same with Frank. He had a descendant take a DNA test. Again, if Robert was a closer relationship, they'd share more DNA. Here's James. Same thing. He had all these descendants take a test. So because they don't share enough DNA, I can just X them out. That only leaves one guy, Clarence. Clarence didn't have any descendants take a DNA test. So I have to do this research myself. Now, sometimes you're stuck here, right? There might be brothers and you can't rule one out for one reason or another. Sometimes you have to look at the records. He died too early. He couldn't have been the parent, stuff like that. But sometimes you can't, and it just has to be between the 2 brothers. And then maybe you try to get a family member to take a DNA test. Or if it's the police doing they'll do surreptitious collection of DNA, or they might, reach out to a family member, say, hey, we're the police. Would you mind taking a DNA test? And most of the time people say, yeah, they want to help the police. And that helps to kind of narrow down this search. But we just have Clarence. Let's see what Clarence was doing. So he was born in 1875 and he died in 1947. So at least we know he was alive in that time that we need him to be for him to be the biological father. And he's in that age range. So guess where Clarence was born? He was born in Hampton, Iowa. Does that sound familiar? It should, because that is where Meta worked as a nurse. She worked as a nurse in Hampton, Iowa. That's nice to know, right? We're feeling pretty good about this already. He was 46 in 1921. He's right in the middle of that age that we need that biological father to be. He married Charlotte Polk in 1900. That means he was married when she became pregnant. And his only son, Hildreth, was born in 1902, which means he was a father when Meta became pregnant. So we know right there, he was married and had a child. Now, what's the last thing that we know about him? He was a doctor, right? So how are we going to find that out? Well, there's a few different ways. First, we find in this 1913 record, he's listed here with his wife as a chiropractor. Oops, you see that? It says chiropractor. That's kind of a doctor, right? Then, interestingly, in 1918, we see he's living in Independence, Iowa, and here he is called Dr. C.E. Millard. But this time he's got optical instruments that were destroyed in this fire. So he was an optometrist, optometrist. Ophthalmologist, that's the other one I was thinking of. Optometrist, we'll say. So he's a doctor. Oh my gosh, we're doing really good here. And then this I loved, 1921. We have Dr. C.E. Millard, an eye specialist from Independence, who was a professional caller in Dundee and fitted a pair of glasses for a woman there. So we know he was a doctor. He was also traveling around, helping people, maybe going back, seeing his family in Hampton, Iowa, maybe doing professional work there as well, maybe meeting a lovely young nurse, maybe having a little love story, right? So what do we have? What are the things that make genetic genealogy, right? We need the science. We need that DNA matching there. We also need the paper trail. Do we have that here with Clarence Ellsworth Millard to be the biological father of Robert Gordon Wick? Well, DNA tests of 8 known descendants of Clarence's parents substantiates the claim, right? We've got the science. The science matches that he fits right into the tree just like we thought. All the results, all of them are within the known centimorgan ranges for that relationship type. There are no outliers. Clarence was of a reasonable fatherhood age in 1921. He was a doctor. He traveled for his work. Perhaps he assisted at Camp Dodge as Meta did. Maybe that's where they met. Clarence had a family in the same town where Meta lived at the same time she lived there. Clarence was married with a child when Meta became pregnant, substantiating the original story. So I took this information to the family and said, in my professional opinion, I think there's great evidence to support that Clarence Ellsworth Millard was the biological father of Robert Gordon Wick. And here's a picture. Again, this is Hildreth Burrell Millard. He was the only son, Clarence's only other son, if we say. And here's Robert Gordon Wick. And they were both about the same age in these pictures. And I like that because I think you can see a family resemblance there. They'd be half brothers. Now, Hildreth himself died very young, and he only had, I think, one son as well. Now, that son is still alive and is living in somewhere in the United States. And when I gave this presentation to the family and told them this story, I said, it's up to you if you would like to reach out to him and ask if he'd like to take a DNA test. Because if he takes a DNA test, you're going to know. You'll see those, they're going to be real high centimorgans. You'll be able to see that relationship. As far as I know, they didn't feel they needed to do that and have not reached out to that family member. Also, if you don't need to, you don't need to. It's up to every person, and certainly don't want to shock a very elderly man at this point, Hildreth's son. So this is where we went ahead and put Clarence as the biological father of Robert and Robert's son Dave into this family tree. And that was very exciting for everybody. And with this, we went ahead and filled out that tree and were able to extend now. Robert Gordon Wick, he still has his adopted family line, right? It's still important, but he also has this biological line of both his biological mother and biological father, and that's through both traditional genealogy as well as genetic genealogy. And that's it. That is our lesson for today. Any questions? Anybody have anything they'd like to ask before we say goodnight? Wonderful. Well, please feel free to reach out to me. You can find my website, lastleafgen.com. Send me an email. If you ever have any questions, I'm always happy to help. I'd love to teach and help as much as I can. So thank you, Alexandra. I appreciate
That was
again,
that was really very good.
Good. Thank you,
Very
Sue.
informative.
Good. And it can be hard, hearing everything one time. Sometimes, we need to learn things multiple times. So
Yes.
always feel free to come back if you're interested. You can always come to another one of my presentations, and I'm happy to help. And if you ever know anybody, again, who needs help finding their biological family, that's something I do for free. I love to do it, love to help. We'll help anybody who's looking for biological family. All right. Well, thank you so much. And I hope
Thank
you
you.
guys all have a wonderful evening.